With this, we have come to the end of the presentation. Please give your comments, if any, about this course after you finished viewing this video. Share with your friends and colleagues to reach out to large number of career-oriented professional students. Thank you for watching. Hello everyone, welcome to Spec eLearn, the online learning channel dedicated to chemical engineers. Process control, modes of process control, part 2. Modes of process control, part 2. In this module, we will discuss proportional integral control, PI mode, proportional derivative control, PD mode, and proportional integral derivative control, PID mode. Please subscribe to the channel. By subscribing, you will motivate me to produce more knowledgeable video content for you. Subscribe now before you forget. In the part 1 of the subject, we discussed in detail two modes of process control, on-off control and proportional control algorithm. The understanding of the proportional control algorithm is necessary to learn and understand the other modes of control, namely PI, PD and PID control algorithm. Those viewers who are not seeing the part 1 are requested to watch the video for better grasping of the concepts. PID algorithm, proportional plus integral mode. Integral mode is also called reset mode. For the experienced viewers, I would like to pose a simple question. How many of you have ever given a thought what type of control mode the plant controllers are using in the plant you are working? If you are not aware, don't worry. This video brings to you what everybody wants to know about. Recall what we learned in the previous video on the proportional controller. The proportional controller cannot keep the PV at its set point if there are load variations. The objective of the integral action is to bring the PV back to set point. That is to say, to eliminate the offset present in the proportional mode. The integral control action is expressed by the relationship MV equal to Kc by Ti integral 0 to T et dt plus I, where MV is the manipulated variable, Ti the integral time, Kc the controller gain, E is the error, and I the initial value of the MV when E is equal to 0. If there is a step change in error equal to x occurs at time t, then the integral mode response will be MV equivalent to Kcx divided by Ti. The integral mode is also called a reset control mode. When error is detected, the controller will respond by taking a proportional action first. Since the PV has still not come back to its set point, the controller will continue to send output to control valve till the error is eliminated. Thus, integral control action is the result of integrated error over time. The longer the error persists, the larger the control action. The integration continues until the error is eliminated. As given in the integral action expression above, The integral or reset time Ti is a characteristic of the integral control mode. While the integral action eliminates the offset, it takes longer time to stabilize at the set point than a proportional control. The integral action also adds to some oscillation to the process response. The combination of proportional integral control, called PI control, takes advantage of both control modes, proportional and integral. The MV in the proportional integral mode is expressed by Kc times e plus 1 by Ti integral 0 to T e dt plus I. The PI control action is additive in nature, that is, the change in control output or manipulate variable or the valve position is the effect of contribution of proportional and integral action of the PI controller. This figure shows the response of PI controller in response to a step change in positive error with respect to time. Initial proportional control action followed by the integral response action is illustrated with P plus I expression. The reset action will sense the error or an offset is present after proportional action has taken place and continue to change the valve position. This process will continue further until the error is eliminated. PID algorithm, proportional plus derivative mode. Derivative is also called rate mode. The objective of the derivative action is to bring about a controller response and produce a control output, which is proportional to rate of change of error or process value. The derivative action does not respond to step change in error. Instead, it responds to a rate of change in error. The derivative term anticipates the change and initiates control response. In that sense, the control mode is predictive. The MV or output of a derivative control mode is expressed as MV equal to Kc into Td times dE by dt plus I, where Td is the derivative or rate time. The larger the value of Td, the faster the derivative response of the controller. This figure shows the response of a derivative or rate controller in response to a ramping error. Observe the derivative response alone. There is a step change in the control output when the rate of error change is detected. In the real-world industrial practices, the derivative mode is not used alone. It is used in combination with proportional mode known as PD mode. The MV in a PD mode is expressed by Kc times E plus Td into dE by dt plus I. This figure shows the response of a PD controller in response to a positive error with respect to time. Observe the proportional response alone. The rate of change of the valve position of the control valve is slower. The rate of change of valve movement in response of the PD control action is much faster because of the rate action. That is, the valve position in PD control mode exceeds that of the proportional control action alone. Also, it takes less time for the valve to ramp up in PD control mode than in a proportional control mode. The fast response is due to the derivative time Td. PID algorithm, proportional plus integral plus derivative mode. Before we move on, I would like to make a call to my dear viewers. Your Spec eLearn channel is a one-stop learning and skill development channel for your career. So do not forget to subscribe. Please press the subscribe button right now. The PID algorithm has all the three modes: proportional, integral or reset, and derivative or range. PID has three adjustable parameters in the algorithm: Kc, the controller gain; Ti, integral time; Td, the derivative time. Kc affects all the three modes. Interval position in response to an error in the process will be decided by adding the effects of all the three modes. The controller output or MV in a PID controller is expressed as MV equal to Kc times E plus 1 by Ti integral of 0 to T et dt plus Td into dE by dt plus I. The major advantage of the PID mode is the elimination of the offset with the faster response due to the cumulative benefits of controller gain, integral time, and rate time. But the challenge is that one has to adjust three parameters in one controller: Kc, Ti, Td for optimum performance. PID control is well suited to processes that are slow or those with excessive lag. The temperature control of reactors or distillation columns are typical applications where PID control mode is extremely useful due to lag in the process. For example, if there occurs a changes in process loads, the system will respond quickly in the case of pressure or level. But temperature change in a system due to the above load changes do not show up immediately due to large holdup of inventory or material in the system. This long lag can be reduced by PID control algorithm. Now let me take you through an example for better understanding. We will examine why the application of PID control for temperature control of multi-component distillation columns in refineries or petrochemical plants is essential for stable and optimized column performance. Illustrated in this figure is a distillation column. We will focus on the reboiler loop to understand the PID algorithm for temperature control. The reboiler steam is controlled by the column bottom temperature. Column bottom temperature is related to the energy balance, and the amount of steam supplied to the reboiler is a measure of energy requirement of the column, which is determined by the feed, the reflux ratio, the bottom product composition, etc. Hence, any change in these parameters will have an impact on the column bottom temperature, and it will take time for the system to respond. PA controller will respond slowly. PID is the most preferred choice for this column control to reduce the lag. This is the block diagram of the PID control. The error is processed by the three modes P, I, and D. An output is generated by the combined action of all the three modes. In applying the PID control, the best control stability performance can be achieved by adjusting the values of the proportional gain, the reset time, and the rate time. This figure shows the effect of the contribution of the derivative action on the PID controlled response. The PA control mode takes longer to respond due to lag time in the process. PID uses the predictive nature of the derivative mode to respond faster and achieve better controller performance. In summary, the characteristics of the different modes of control are: 1. Proportional mode, offset persists; proportional integral mode, offset eliminated but takes long time to stabilize; PID mode, no offset and faster response to error. Please subscribe to our channel and get updates on the upcoming courses by pressing the subscribe button. It will motivate us to produce free, knowledge-rich video content for you. With this, we have come to the end of the presentation. Please give your comments, if any, about this course after you finished viewing this video. Share with your friends and colleagues to reach out to large number of career-oriented professional students. Thank you for watching. Hello everyone, welcome to Spec eLearn, the online learning channel dedicated to chemical engineers. Process control measuring instruments, types of temperature sensors and their applications. In this video course, you will learn the importance of measuring instruments and what is temperature sensor, field system thermometers, electrical system thermometers, radiation type or infrared temperature sensors, infrared thermography. Please subscribe to the channel. By subscribing, you will motivate us to produce knowledgeable video content for you. So subscribe now before you forget. The first step in process control is the measurement. Anything which cannot be measured cannot be controlled. The measuring element is called the instrument. Not just the measurement, but measuring with accuracy is key to reliable operation and control of the process parameter at the desired value. The important process parameters which need measurement for process control are temperature, pressure, flow rate, level, concentration, etc. Temperature is an important and critical parameter in many processes. The processes need accurate and reliable sensors to measure the temperature, not only for monitoring purpose, but also for control function. What is temperature sensor? Temperature sensor is an instrument that is designed to measure and indicate the temperature in a specific application. These applications varies from measurement of temperature in utility services to furnaces, boilers, reactors, distillation columns, etc. There are several types of temperature sensors. The choice of temperature sensor for a given application depends most importantly on the characteristics of the sensors. Temperature sensors are broadly classified under two categories: field system thermometers, electrical type thermometers. system thermometers. A filled system thermometer, also called dial thermometer, is a temperature measuring instrument consisting of the following: a thermal system and an indicating system. A thermal system is a closed system filled with temperature sensitive fluid and has the following components: a bulb, an expansion device, a capillary tube connecting the two. There are 4 types of filled system thermometers used in the industrial applications depending on the thermal system: liquid filled thermometers, vapor filled thermometers, gas filled thermometers, mercury filled thermometers. The liquid filled system thermometer is completely filled with liquid and works on the principle of expansion, that is, volume increase of the liquid as the temperature increases. The temperature range of application is minus 210 degrees centigrade to 315 degrees centigrade. Organic liquids, pentane and butane, can be used as liquid for this range of application. Typical applications include food and pharmaceutical, where mercury-filled thermometer cannot be used. Vapor-filled thermometer. The vapor-filled system thermometer is partially filled with volatile liquid and works on the principle of increase the vapor pressure of the liquid as the temperature increases. As the vapor pressure increases, the Bourdon tube expands, moving the indicator. These systems provide quite accurate measurement. The liquid for the system is selected depending on the temperature range of the measurement. Ethane, acetone, ethyl benzene, and ethyl chloride are used as liquid. With ethyl chloride, the temperature range of application is 40 degrees centigrade to 175 degrees centigrade. As per the equation, PV equal to N or T. Since the volume of the fluid system is constant, an increase in temperature will result in an increase in pressure. Nitrogen is usually used. The temperature range of application is minus 210 degrees centigrade to 315 degrees centigrade. Shown in this figure is a gas-filled temperature sensor. It has a stainless steel bulb filled with nitrogen gas and a long capillary tube for remote fixing of the dial gauge. Gas-filled temperature sensors are used for the widest range of temperatures in the filled system category. Applications include chemical processing, control panel, pipeline applications. This figure illustrates that a typical applications of a filled system thermometer for local indication of temperature of a liquid flowing through a pipeline in a tank form. Mercury-filled thermometer. In this filled system temperature sensor, the bulb is filled with mercury metal, which expands as the temperature increases. Since mercury is toxic, it is not widely used in industrial applications. Filled system thermometers can be used for direct mounting or remote indications. Gas-filled thermometers can be used for remote indications with capillary length up to 100 feet, whereas liquid-filled systems are used for remote indications up to 25 feet or less. Electrical type temperature sensors. Before we move on, I would like to make a call to my dear viewers. Your Spec eLearn channel is one-stop learning and skill development destination for your career needs. Get instant access to useful career-oriented subjects and become knowledgeable and competent. So do not forget to subscribe. Please press the subscribe button now. Electrical system temperature sensors fall into two categories: thermocouples, resistance temperature detectors (RTD). Thermocouples. A thermocouple working is based on Seebeck effect. According to Seebeck effect, when a closed circuit is formed by joining two dissimilar metals at two junctions, and the junctions are maintained at different temperatures, then an electromotive force EMF is induced in the closed circuit. The amount of EMF produced is different for different metal combinations. The EMF produced is proportional to the temperature difference of the junctions. Shown in this figure is a sketch of a thermocouple consisting of two dissimilar metals joined at two ends, with one junction kept at the unknown temperature or the temperature to be measured, and the other junction at the reference temperature. The junction kept at the temperature to be measured is called the hot junction, and the other junction is called the cold junction. The thermocouple wires are chosen so that the EMF produced varies linearly with the temperature. The relationship between the temperature difference and the EMF produced given by ETC is a function of TH minus TC, where ETC is the EMF generated by the thermocouple in millivolts. TH is the temperature of the hot junction in degrees centigrade. TC is the temperature of the cold junction in degrees centigrade. This table presents the typical thermocouple metal combinations and their temperature range. The EMF developed with the thermocouple vary with the metal combination. For example, copper and copper-nickel combination can be used for temperature measurement from minus 200 to 400 degrees centigrade. Shown in this figure is the thermocouple temperature sensor. Note the cold and hot junction as marked. This figure shows the use of thermocouple in a catalytic cracker unit. Thermocouple is used to measure the metal wall or skin temperature of the catalyst tubes inside the furnace, typically in furnaces and fire heaters. The thermocouple for the hot junction is made in the form of a pad as shown in the figure, so that the pad is fixed to the tube surface by welding or other means. Thermocouples are most common type of temperature measuring instrument used in the industry today. Their wide acceptance is due to the simplicity, ease of use, speed of response to variation in temperature. Resistance temperature detector (RTD). Resistance temperature detectors are temperature sensors that make use of the principle of the variation of electrical resistance of a wire with its temperature. The relationship between the resistance of a wire and temperature is expressed as RT equal to R0 times 1 by alpha T. Where RT is the resistance at temperature T. R0 is the resistance at temperature reference temperature, usually at 10 degrees centigrade. T is the temperature of the medium being measured. Alpha is the temperature coefficient of resistance. RTD used in industries are usually made of platinum, nickel or copper. Platinum RTD is the most common type of RTD used in the industrial applications because platinum has excellent corrosion resistance, excellent stability over a long period of time, and can be used for a wide range of temperatures. Platinum RTD is used for temperature range from minus 200 degrees centigrade to plus 800 degrees centigrade. Nickel RTD is used for low temperature ranges, typically minus 80 degrees centigrade to 250 degrees centigrade. However, it has lower stability compared to platinum, and measurement accuracy reduces with time. It is less costly compared to platinum. Copper RTD has the best resistance to temperature linearity and is low-cost material. However, it oxidized at high temperatures and hence limited to temperature range minus 200 degrees centigrade to 260 degrees centigrade. This figure illustrates a typical RTD temperature sensor. The platinum wire is wound around non-conducting core. It is usually made of ceramic. Lead wires are used to connect the platinum resistance wire to the transmitter. The transmitter converts the resistance measured into the corresponding temperature. A fully assembled RTD temperature sensor is shown in this figure. A typical RTD has a base resistance of 100 ohms at 0 degrees centigrade, increasing to about 140 ohms at 100 degrees centigrade. Though platinum is the most widely used RTD, the major disadvantage is its cost. RTDs are widely used in distillation column in refineries and petrochemical plants. They are the de facto standard for distillation columns. However, thermocouples are used when the temperature of the fluids to be measured exceed the maximum allowable limit of RTD sensors 800 degrees centigrade. We will see some more applications of vertical system temperature sensors in refineries and petrochemical plants. Shown in this figure is a catalytic reactor whose bed temperature is measured by as many as 14 RTDs placed at the top, middle, and bottom of the reactor. This figure shows another application of RTD in a multi-stage centrifugal compressor. A compressor has 7 number of RTDs installed in the process loop for monitoring the suction and discharge temperature of each stage. Radiation type temperature sensors, also called infrared thermometers. Radiation type temperature sensor detects the infrared radiation emitted from the surface of the object and measures the temperature based on the amount of infrared radiation. They are the simplest devices and cost less. Infrared is that portion of the electromagnetic spectrum beyond the visible response of the human eye. Because infrared is predominantly generated by heat, it is called thermal radiation. Pyrometer is an infrared remote sensing, non-contact type thermometer. It is usually used for measuring relatively high temperatures normally encountered in furnaces and fired heaters. The optical system of the pyrometer focuses on the energy or the radiation emitted by the high temperature surfaces on the detector. The detector is sensitive to radiation. The output of the detector is proportional to the radiation energy emitted by the hot surface less the amount absorbed by the optical system. Since the radiation energy is a function of the surface temperature of the tube, the pyrometer detector output is indicated as surface temperature. Shown in this figure is an infrared temperature sensor. It is the emissivity of the tubes that is used by the pyrometer for measuring the temperature. Emissivity defines the fraction of the radiation emitted by the object compared to that emitted by a perfect radiator, that is a black body, at the same temperature. Emissivity is simply a factor by which we multiply the black body heat transfer to take into account that the black body is the ideal case. Thus, the pyrometer output is expressed as thermometer output proportional to epsilon times T, where epsilon is emissivity. The dimensional number is equal to 1 for a black body. T is the object temperature. Infrared thermography. Infrared thermography is used in refineries and petrochemical plants for monitoring critical assets such as fired heater tubes and coils, catalytic reactors, and their refractory conditions. Refractory is a liner material consisting of high temperature resistance material which protect the outer shell of the furnaces, reactors, etc. If the refractory fails, the shell material will be quickly weakened by the inside temperature, which may be in the range of 1200 to 1400 degrees centigrade. This poses a significant risk of equipment failure. Infrared thermography, also called thermal imaging, is used to monitor and survey the conditions of refractory, lined catalytic reactors, piping and fired heaters on a regular basis, and process team uses the data for preventive maintenance if needed. This figure illustrates thermal imaging of a hot air line where the refractory lining has failed. The picture at the top is the actual hot air line piping lined with refractory. The picture below is the infrared thermal imaging of the pipeline, which shows the refractory has failed. Please subscribe to our channel and get updates on the upcoming courses by pressing the subscribe button. It will motivate us to produce free, knowledge-rich video content for you. With this, we have come to the end of the presentation. Please give your comments, if any, about this course after you finished viewing this video. Share with your friends and colleagues to reach out to large number of career-oriented professional students. Thank you for watching. Hello everyone, welcome to Spec eLearn, the online learning channel dedicated to chemical engineers. DARATIS, understanding the principles and design considerations. In this video course, you will learn why DARAT is required for boiler, the operating principles, the design considerations, and construction features. Please subscribe to the channel. By subscribing, you will motivate us to produce knowledgeable video content for you. So subscribe now before you forget. Deaerator is an important equipment in boiler system in process industries and several other industries, including power plant. Corrosion of condensate in boiler tubes is a major concern in the above industries. While corrosion is a general topic that will be covered separately later, this discussion focuses on corrosion by dissolved oxygen and carbon dioxide in condensate and boiler, and the removal by mechanical means. Oxygen in the condensate sets up corrosion seal. The iron from the condensate pipe and steam system dissolves by the above corrosion cell formation. The corrosion reaction and material dissolution in water is explained by the two reactions below. The first reaction forms a hydroxide protective layer on the metal surface. iron plus 2H2O, giving rise to FeOH twice plus H2. The dissolved oxygen water then reacts with the ferrous hydroxide protective layer and forms insoluble deposit called rest. 4FeOH twice plus O2 plus H2O, giving rise to 4FeOH thrice. Similar effect is possible from the presence of carbon dioxide in the steam system. When the steam containing CO2 starts to condense in the heat transfer equipment, the CO2 dissolves the condensate, forming carbonic acid. 2H2O plus 2CO2, giving rise to 2HCO3 plus H2. The carbonic acid is a weak acid and dissolves iron from the condensate pipes and vessels. The effect of corrosion products. Having understood how dissolved oxygen and carbon dioxide in condensate system and make up boiler feed water causes corrosion, let us move on to find out how it impacts the boiler tubes. This corrosion attack by dissolved gases is identified by the pitting of the metal surfaces in the piping system and boiler tubes. The iron dissolved from the condensate piping, when reaches a boiler, can deposit in the high heat flux areas in the boiler, that is the tubes. The deposit acts as an insulation layer on the tube surface, minimizing heat transfer that leads to excessive surface temperature. As the deposit layer grows in size, the heat transfer is reduced significantly and the overheated tube fails by rupture. No plant operating personnel want to see this happen. It has huge cost impact on boiler maintenance and plant operation and capacity utilization. You know the effect, but how to remove the dissolved gases? Prevention is better than cure. There are mechanical and chemical means to reduce a corrosion attack by dissolved oxygen and carbon dioxide. Chemical means will be covered separately. This video focuses on the mechanical means, that is, by deaeration. What is deaeration? Deaeration is a removal of dissolved gases such as oxygen and CO2 from the condensate and boiler feed water before it is fed or returned to the boiler. Deaeration is based on two principles. The first principle is the Henry's law that states that gas solubility in a solution decreases as the gas partial pressure decreases. The second principle is that the gas solubility in a solution decreases as the temperature increases and as it approaches the saturation temperature, that is the boiling point. How do you apply these principles in the deaerator to remove the dissolved gases? The deaerator applies this principle by use of steam and also use stripping to remove and release the dissolved gases to atmosphere through the vent in the deaerator. Shown in the figure below is the design and construction features of deaerator system. The deaerator system consists of a deaerator and a holding tank located just below the deaerator. The removal of dissolved gases take place in the deaerator, which consists of several rows of perforated trays fitted inside. Steam is admitted to the deaerator at the bottom, and the condensate returned from the steam system and the fresh boiler feed water enters the top of the deaerator and is distributed over the trays by spray nozzles. Thus, the water and steam flow countercurrent to each other. The falling condensate and boiler feed water comes into contact with the outflowing steam on the trays and gets heated up to the saturation temperature. The deaerator is maintained at atmospheric pressure by a vent nozzle which is open to atmosphere. Hence, the water is heated to the saturation temperature of 100 degrees centigrade. A small quantity of steam is allowed to vent to atmosphere. This ensures the condensate and the boiler feed water approach the saturation temperature. As explained in the principle earlier, the steam reduces the positive pressure of CO2 and oxygen in the system and raises the temperature to the saturation temperature. The net effect is the reduction of gas solubility in water and hence lower residual gas concentration in the boiling fluid water to the boiler. The counterflow arrangement of water and steam ensures good removal efficiency. What should be the dissolved oxygen content in the feed water to boiler? ASME provides the standard for the condensate and boiler feed water quality to boiler in terms of boiler pressure. The following table provides the recommended dissolved oxygen content in the feed water to boiler versus steam pressure. For boiler pressure up to 450 psig, the recommended dissolved oxygen should be less than 0.04 ppm, that is 40 ppb. For boiler pressures greater than 450 psig, the recommended value is 0.007 ppm, that is 7 parts per billion. Deaerator design aspects. Three important design parameters in the deaerator are pressure in the deaerator, turbulence and sufficient residence time, and steam requirement. Pressure in the deaerator. Operating pressure of the deaerator depends on the amount of gases to be removed. For very low level of oxygen concentration, low pressure, slightly above atmospheric pressure in the range of 0.2 to 0.5 bar G is preferred. Turbulence and residence time. Turbulence helps in breaking the surface tension of water and aids in release of the gases. The resonance time must be sufficient enough to shift the gases of water. Perforated tray section provides a turbulence as the steam passes up through the perforations. The number of trays is selected so as to give sufficient resistance time. Steam requirement. The quantity of steam required depends on the ratio of the boiler feed water makeup and the condensate returned. Higher the boiler feed water makeup, larger the quantity of steam needed. As explained before, the steam is needed to heat the condensate plus makeup water to the saturation temperature in the deaerator vessel. In addition, small quantity of steam is required to physically strip the gases and release them to atmosphere through the vent. Most of the steam admitted to the deaerator condenses on the trays. A small fraction of steam is lost with the dissolved gases in the vent. Steam requirement can be obtained by making a steam balance by specifying the condensate and makeup water temperature and ratio of makeup water to condensate returned. If the deaerator system receives a return condensate at high pressure, then it will generate some quantity of flash steam. The flash steam generated should be subtracted, and the steam that is lost with the non-condensables in the vent should be added. Please subscribe to our channel and get updates on the upcoming courses by pressing the subscribe button. It will motivate us to produce free, knowledge-rich video content for you. With this, we have come to the end of the presentation. Please give your comments, if any, about this course after you finished viewing this video. Share with your friends and colleagues to reach out to large number of career-oriented professional students. Thank you for watching.
Hey everyone, welcome to Simply Learn. Today, we will be learning the Project Management Fill course. We will begin this video by talking about what project management is, project planning, how can it be done using Excel, cost, quality, communication and other forms of management, the best project management tools, how you can prepare for the PMP exam, the role of a project manager, interview questions and much more. By the time we are done, you'll be well versed with some of the most important concepts in project management. For this training with me, we have our specialists Chandra MR and Ishan. Together, they will take you through these different topics. So, let's start by answering our first question. What is project management? So before we begin, make sure to subscribe to our YouTube channel and don't forget to hit that bell icon so that you can never miss an update from Simply Learn.
Hi, welcome to Project Management tutorial from Simply Learn. I am Chandra MR, a professional consultant and coach in best practices related to project management and IT service management. Today, as part of this tutorial, we are going to learn the basic understanding about the project management and the required knowledge for a project manager to become successful in managing projects. So as part of this tutorial, we are going to look at what is project management, what is project, components of project management, project life cycle, key focus areas in project management, job roles in project management, and project management certifications. So what is project management? Now as defined in PMI's PMBOK, project management is application of knowledge, skills, tools and techniques to project activities to meet project requirements. So every project will have an objective to accomplish. Similarly, the objective of project management is to make the final deliverables in a finite time and budget. This involves having clear understanding about the deliverables of the project, required resources for the project, resource in terms of human resources, technical resources, financial resources, etc. Project manager should have a full picture of those aspects. We can call it project manager should have a full view about a project and what is that this project has to accomplish. That objective should be clear. So as part of project management, the 6 constraints which project manager should look at are scope, time, quality, cost, risk and resources. So each of these areas has very important role to play in project management. The clarity in scope, the clarity in terms of schedule within which the project has to be delivered, the cost, what it incurs to that particular project. Once it is finalized, one cannot vary, one cannot change without any proper approvals. Similar to that, we have quality management specifications what are defined. Project output will be accordingly achieved. Risk, every project is taken up for a specific reason by organization. So organization should assess the risk associated with the project, and similarly as project progresses, various different risks has to be identified, like risk related to project management, risk related to technology area, risk related to resources, risk related to financial things. So broadly, risk management plays a very important role. So there will be something called contingency reserve kept for a identified risk above the cost what is estimated is deliverables from the project. So every project requires resources. Resources may be in terms of human resources, financial resources, technology resources, environmental resources. So all these resources are used to produce the output of the project. So these resources has to be managed with the sufficient optimization and standardization is required. Now let us understand the definition of a project. So what is a project? PMI defines a project as a temporary endeavor undertaken to create a unique product, service or result. The temporary nature of a project indicates that a project has a definite beginning and end. So when I say product, unique product, it means every output, it may be similar products you are producing with the same features and functionality, but the output of every project is unique because it is unique in terms of all the 6 constraints what we just discussed now. Now when I say product, it is very easy for us to visualize. It may be a desktop, it may be a laptop, it may be a car, it may be a machine, etc. But how do I visualize a service? A project output is a service. Now it's about building a capability. A project, through a project, a capability can be built to ensure services can be provided. That's what the output of project is, service. For example, if I think about a taxi services, for providing a taxi services, I need a mobile app, I need taxi, I need a server, I need a data center. So all these are various different products and services. Here service example can be internet service. So combination of all these services and products builds the capability for an organization who can provide the taxi services. So building that capability, we say it is an output of a particular project which is called service. Similarly, results can be improvement of something, improvement in customer satisfaction, increase in some specific objectives or specific results need to be achieved in performance perspective. So output of every project will be unique product or a service or a result. This we need to clearly understand. So when we say there is a definite beginning and end, every project starts at a certain point in time and ends at certain point in time. So it has a definite beginning and end. That is the reason it is temporary in nature. It is not an ongoing business activity, right? So every project will have a life cycle, a beginning and end. So when it starts till end, until the result or a service or a product which comes as an output of a project life cycle is not ended. So interestingly, in a product life cycle or in a service life cycle, you come across many project life cycles. So one project life cycle means one project is initiated to introduce a product or services. Next project or initiated would be to enhance the capability of a service or a product. Next project initiated after some time is to optimize something. Similarly, at the end of the product life cycle, project is initiated to retire that product or services. So in a given product life cycle, there may be multiple project life cycles. So what is involved in the project life cycle? It involves 5 areas, 5 groups we can call it as. So initiation, planning, execution, monitoring and closure. So when I say initiation, it's all about understanding what is project, giving the basic understanding of the project, collating the details and having key stakeholders identified. Once that is done, one will move towards planning. So here in the initiation, it is very clearly one has to understand this project is worthwhile of doing. So one has to check the feasibility, one has to measure that particular investment is making sense and then confirm, yes, it makes sense to invest. Now next, planning. As we have a basic understanding of, yes, this project has to be done and a discussion with the key stakeholders have happened, now that moves towards planning. Now in planning, one will understand the project in entirety. If it is a waterfall approach, one has to have a clear articulation of entire project, a comprehensive details, holistic approach. Now if you're going in a project in an agile way of approach, now in this planning you may have a big skeleton. As you go in each of the iteration, you may go deep dive into detailed planning if it is an agile approach. So planning provides you the clear insight towards what needs to be done in this project, how it has to be done and what are the results which can be achieved out of that particular project. So this involves making that a clear blueprint of an project objectives, what we are supposed to achieve. So this will become a reference point throughout the project life cycle. Then execution. As you have a blueprint of the project, as the direction of that project is set, detailing of the project has been made, one will go ahead and implementing it. So execution phase involves the allocation of resources and making the deliverables as required. You acquire resources, you configure a resource, you ensure right resources are acquired. If it is human resource, one has to educate that human resource with the project required knowledge or details, or one has to provide that assignment in such a way that skills of that individuals, what they should have is acquired by those individuals so that deliverables can happen and they needs to be managed. The entire team needs to be managed. For that, a clear structure has to be created. Similarly, when you do technology resource perspective, those components has to be tested, configured, then integrated, again tested for and check the performances. So collective action of this results in a deliverable during the execution. So as the deliverables are happening in the execution, it is quite obvious project manager has to monitor, review, control that particular deliverable and also the processes, tools, resources used during the project, even those needs to be monitored so that they are complying to the defined processes. So during monitoring, there may be a deviation one can found. During monitoring, there may be the project is running the way it is required. So in this monitoring phase, it involves an action from project manager to monitor and control the work of the project. So comparing with the blueprint of plan, what is accomplished, what is created during the planning phase of this project, and as the execution happens, monitoring and control is monitoring it and checking is that activities what is being done is according to the plan or not. Similarly, the deliverables which comes as an output of a project are tested thoroughly, whether those have a specific features and functionality and are they functioning the way it is required. Now project has to be delivered to the scope what is defined, it should not go beyond that or below that. Similarly, the schedule what is made for the project, within that schedule project deliverables has to be accomplished within the cost what is budgeted for the project. So during the project, the project manager may find there are certain deviations which are occurred, there are additional challenges which has come in. So for this reason, one has to ensure continued monitoring as the execution happens and identify those deviations and ensure whenever there is a deviation, there is a correction. Whenever there is an additional things coming in, that needs to be considered carefully whether that need to be involved as part of this deliverable or should be taken it separately. So this requires a lot of conversation with all the stakeholders of the project during the entire project life cycle, especially during planning, execution, monitoring and control, since they are not the one which is happening in sequence. So planning can also come back again where there is something which you may require to modify. So you may require to have a change in the blueprint itself. By adding that, new changes coming in. So you go back to planning. So planning, execution, monitoring and control are going hand in hand so that project deliverables are happening as needed. Similarly, all the process, work instructions, all those templates what is given are used. One is complying to those requirements. It is very important. And project is done within the scope, schedule and time, and the quality metrics defined. Then as the completion of the project happens, as the monitoring and control says, yes, deliverable has happened according to the requirement, then the project moves to the closure. The closure may be closure of a specific project phase, a milestone deliverable or a phasal deliverable, or it can be a deliverable at the end of the project, which is the ultimate deliverable. So processes in closing has to be triggered whenever there is an end of the phase, whenever there is a deliverable to conclude, and also at the end of the project to conclude the entire project. So during the closure, one has to ensure capturing all the details in terms of what is accomplished against what is defined, what went wrong, what went well, what is the learning one has to take to the next level or the next phase or to the next project. And at the same time, a sign-off has to be obtained formally and everything should be summarized and have a good handshake with the project stakeholder, mainly a business or customer, and also disseminating of team means you will dismantle the entire team and send them back to their specific units or specialization, and they may get assigned to new project, or if it is a functional, they can go back to their functions to do their functional activities. So that was about entire project life cycle what happens. Now while doing this, I mentioned there are 6 constraints, that is scope, schedule, cost, quality, risk and resources. So keeping these in mind, one has to ensure project is successful in all aspects. So to become successful, there are 2 key areas which has to be looked at. So first 6 key areas are scope, schedule, cost, quality, resources and stakeholders. Now let us look at the scope. What does scope means? Scope is about what needs to be delivered. What is in scope? What is out of the scope? So this refers to all those deliverable scope, all those activity scope. Basically we speak about 2 things. One is product scope and project scope. Product scope is all about ensuring the features, functionality of products are well defined and understood and signed off. And while delivering that product, that is tested against those defined features and functionalities. Whereas project scope focus on all the activities needs to be done, all those templates which has to be used, all the process which has to be complied with, all the skills which is required to be applied. So it is going as defined. So by doing this activities which is defined as part of project scope, the result, the deliverable will come out, which will be in line with the deliverables, features and functionality, which is defined as part of product scope. It is very important to ensure entire project happens within this particular scope. There should not be any deviations from this. Schedule perspective, for that specifications what we have defined for the product and project. So these needs to be done in a specific point in time, means in a specific schedule. There will be start time, end time, right? So one has to plan how long a project would take and what are the deliverables should happen in what sequence, what activities are required to accomplish this. So all these needs to be understood. So while performing the schedule management. One has to look at a specific deliverable at a specific point in time by applying a specific set of activities required. So this will tell you the duration of the project. This will provide you the sequence of project. This will also help you to understand the dependency between one task to another task. This will also help you to understand how the deliverables happening in what sequence, which helps in prioritizing your deliverables. Third is cost. So as we know, to do any project, it is very essential to ensure project happens within that budget. So project cost is estimated initially, then that estimated cost will be checked in terms of is the assumptions, considerations are right or wrong. Is that really so much of monetary resources are required for the project? And then after understanding the justification and obtaining the clarity, budget is, monetary resources are allocated and confirmed, approved. Then it will become a budget. That will be a cost baseline. So these estimation, allocation of budget, once it happens, that will become a base, and any deviations from that cannot happen so easily. So any deviations because of additional of scope that can be handled through change management, but idealistic scenario, the cost should not escalate or come down. Organization can also set certain tolerances at the project level, considering various different scenarios, like scenario of risks, scenario of something which deviated from the deliverable. So to what extent it can deviate, that tolerance will also be set at the economic or monetary value perspective. That is about cost. Now, quality, as we know, quality is a very important area which ensures the project is delivered in time with all the specifications defined by using all the methods, means by following all the processes, work instructions, templates, and delivering as needed, where it enables the project to monitor it easily. So basically, the requirement of compliance and standardization and optimization is to ensure everyone follows the same steps, do the activity. So what quality management focus is to ensure the intended objectives of the projects are achieved. Already there is a definition done in terms of various different practices or processes needs to be followed. Similarly, specification of each of the products are defined, and from that there should not be any deviation. So quality management should focus on ensuring those activities are done as defined, those deliverables are done according to the specifications what is defined. It is very important that way. So for that there is a layer of quality management, there should be a layer of quality management where auditing or control activities are initiated periodically so that any deviations can be seen easily. And remember, a project manager cannot become part of quality management. Like project manager cannot audit. Project manager should have a team or take the help of a team who can able to do. Mostly the one who is not part of the project is always better. Resources. Now, as I mentioned earlier, every project needs resources. It may be human resources, it may be technology resources, it may be any other resources which are required to do the project. So organization acquires resources, configured and then deployed. For example, in a project, you acquire a server, you configure a server, you deploy a server. Technology resource. Human resource is onboarded, recruited, project induction is given. Then at the same time, the skills and capabilities of individuals are according to the requirement of project. That needs to be ensured. And what needs to be delivered and how it has to be delivered should be clear to a particular human resource. So looking at all the aspects of resources to acquire, to build and manage, it is very important to look at the resource management. So this will help in carrying out a specific task in a project in the best possible manner. So interestingly, when I say human resource, always there is a possibility that a conflict can occur. So when I say conflict of interest maybe in terms of what the individuals has to do, conflict in terms of the preferences, in terms of solutions, what they are looking at, conflict in terms of using resources, different opinions, different preferences, various reasons conflict can come across. So it is very important to project manager to understand this dynamics of human resources and manage these conflicts. Project manager cannot shy away from handling conflicts. Project manager has to hone and resolve these conflicts in the favor of project, not in the favor of any individuals. So there are various techniques to look at resolving conflicts. So that is like compromising, problem solving, smoothing, accommodating. So whichever helps for that project scenario, for the project objectives, that needs to be applied. That technique has to be taken up. So here The resolution is not at the specific individual's preference. It is with the objective of whether projects has any impact. What kind of impact? Positive or negative? If it is negative, no, that's not the direction. The direction should be ensuring project gets that value through this conflict resolution. So project manager should own it. It's an accountability of a project manager. Then as the human resources are acquired, there are 5 stages. Team dynamics are involved. So one has to bring them, then educate them about a project. As the education on the project happens, one has to go and do the job on floor. That needs to be observed. Means one has to manage by looking at it, and any corrections needs to be done. That needs to be guided. So it is very dynamic thing when it comes to human resources. Similarly, in technology resources, standardization. There is no ambiguity as such, but right resources with the right configurations should be acquired. That is very important. The next, stakeholders. So who can be stakeholders? Every project will have a stakeholder who are internal and external to the project. So the internal stakeholders are those.
Rồi cái này nó qua cái video khác rồi ha, không cần coi cái này. Rồi như vậy lớp của chúng ta ôn cái nội dung của cái kênh cái nội dung video vừa rồi ha. Sau đó chúng ta
Hello, everyone.
hoàn thiện cái bản báo cáo. Rồi liên quan cái nội dung lớp coi có câu hỏi gì không? Rồi dữ rồi.
Hello, everyone.
Trung quy ra mấy cái video còn nắm cái
Số lọc.
mấy cái bộ điều khiển mà thầy kia thầy em thấy nó nói điện hóa rồi.
Đúng rồi, điều khiển quá trình là người ta tập trung vào cái phần tử của quá nhiều hơn.
Dạ. Thì là chủ yếu mình rút ra được mấy cái điều khiển nhiệt độ với điều khiển mấy cái
Không, mình phải chọn tìm hiểu đầy đủ cái nội dung chứ không phải là mình lấy ra chọn ra để tìm hiểu đâu. Mình tìm hiểu tất cả các nội dung. Rồi thì chúng ta cứ tìm hiểu các nội dung, có phần nào mà chưa rõ thì có thể đặt câu hỏi rồi tôi trả lời ha, hoặc là nhờ thành viên nào biết thì trả lời. Rồi nếu không có thắc mắc gì thêm thì hôm nay chúng ta chỉ xem phần đó thôi. Rồi chúng ta dừng, hẹn gặp lại vào tuần sau ha.